Greetings, integrated math superstars. This is going to be what I call a pregame for the upcoming Desmos lab. These videos are going to help us make the most of our time together as we work in Desmos labs. So we'll talk over some of the vocab, what the goal is, some things that I think are easier to knock out ahead of time before we move into the actual lab. Gives us more time to actually interact with the material and get a feel for how you interact with what's being put in front of you. Sound good? Seem okay? While we're working through this, please make sure that you're taking notes on the vocab along the way. Again, the whole idea here is that you're getting a quick glimpse to the vocab and what the section's all about in comparison to trying to copy down the vocab while we're in the middle of the lab. So we'll start this off with 1.3. Sounds good to me. We see that with 1.3, we are growing dots, not just once, but twice. And we see a few reoccurring things here, in particular, that we have a geometric sequence. Ooh, what's that? We'll soon find out. We also see a change, well, not too much of a change because recall previously we were representing using equations, tables, graphs, and story context. So previously we probably set up an equation that said the the current equals the previous plus 5 or something to that effect. We should have hopefully gotten to the f of n notation. And if we're talking about the previous term, f of n minus 1. As far as the table goes, we've dealt with x, y, seen those sketched out. In the most recent section, we saw the change from minute to minute and the number of dots that were created based off of the number of minutes. So recall in the previous section at 0 minutes at the beginning, there was just 1, then it went to 5 and it increased from there. So the table is another way that we can talk about what's going on. We also see a little bit of the graph come back again here where, we start with some value and then we keep measuring that change. And hopefully it's a consistent change of just adding 4, but we'll soon see that that's not always the case. So this section builds off of what we've seen previously and just tweaks it a little bit further. So I hope that's okay with you. We see that we have a pattern starting with the beginning at 1 minute, 2 minutes, 3 minutes, 4 minutes. We will meet together and talk about that. We'll talk about that in words, talk about an equation that goes with it. That'll all be nice. But this is in particular is what I'm looking for. So some vocab that you should be copying down deals with a geometric sequence, which you might say, oh, that sounds kind of familiar. Like, I think that's something we did. And in a way we did, but notice with geometric, this isn't quite arithmetic. Arithmetic we've seen before, geometric slightly different. And let's see why. Well, this is also a sequence, but now it has a common ratio between consecutive terms. So we see that in this notation here, a common ratio occurs if we have f of n plus 1. So let's say if we have f of 3 up here, and this is just f of n, what's going to have to be the input down here? What do you think? Well, we see that the top is n plus 1, so that means if we deduct 1, this would have to be 2. And so this allows us to create a common ratio. And we'll soon see why this is important in the lab, but for now, just take this at face value. Think of this as a good example. Okay, that clears up that. Let's see what else we got in here. Of course, if you need to, pause the video, copy that down, which you should have done already, but definitely make sure this is in your notes. We then see a challenge and some takeaways. So really the only vocab that's introduced here is the idea of a geometric sequence and the common ratio, which are going to be 2 terms that come up quite a bit. I hope that this video is helpful and helps you make the most of 1.3. If you have any questions, let me know ahead of time. Thanks for watching.